just 3 seconds about who am I. I'm Kris, as some of you might know. I've been involved in Linux and open source since the past decade and a half. I'm what I call myself an infrastructure architect. I'm not a DBA, definitely not. I've been using Linux since whatever, that's somewhere 92, 93. I'm not a kernel hacker. I use the acronym because some people, when they start their presentations and they talk about legal stuff, they have to say I'm not a legal advisor. So I'm not a kernel hacker. And I'm the guy who founded Extend after we had some problems with Stone acting in the Netherlands. So let's talk about MySQL. Most people that are using MySQL have no problems. Not you're an exception and you have a luxury problem. There's no problem because our application does exactly what MySQL used to be written for, which was small databases, small applications running on a small environment. Today those things changed. Today we have the internet, we have 24 applications that are being used by the whole world and not just by the 5 developers in your room. So people often get the idea that MySQL is slow. Well, nothing is less true, because if you look at performance studies, MySQL easily outperforms Postgres, and next month Postgres will outperform MySQL. But Oracle already admits that they have a performance diminishing problem. But why do people think MySQL is slow? Basically because the applications that are being written by the developers suck. They're not already told. People don't use indexes. So what do we do when we have a problem with MySQL? You look at which queries are being run. You look at how they are being generated. And what you see is that people run select on databases that have no indexes. And of course they're slow. And when I mean no indexes, they don't even use indexes on index fields. So the first rule when you start using a database for your application is use indexes on the relevant fields. The second problem we run into is that people tend to stop writing their own code and start generating code. And a perfect example of that is people that are doing GBoss, J2E platforms, and they are using Hibernate or other code generation tools to actually generate the queries they are going to use on their databases, which results in what I call the China syndrome, because the first time I had to actually debugging is when I was lying ill in my sofa at home and had a problem on a machine in China, which was at a load of 9, and we saw no action going on there except a constant feed of about 10 megabytes of queries per second. And nobody knew which machine was doing what. And there was one GBoss that was launched on a secondary server, and it was only collecting data and doing 1 query per minute. That was the intentional idea of the developer. But what he didn't know was that Hibernate generated queries at about 1 megabyte per query in the style of select alias query field, comma alias field, comma alias field, comma alias field, comma alias field, from table alias, table alias, table alias, joined by table alias to alias, where blah blah blah. And what he actually wanted to do is select ID from table, which had no relationship at all with other tables. 1, we didn't need the application. 2, we didn't need all the other data. But the database was running at load because it was parsing stuff like, oh, results at 0. So why is MySQL slow? Not because MySQL is slow, but because people don't know how to write code. That's one part. The second part is when your application actually becomes slow. And I have to be rude with you guys, but that's a luxury problem. I hope that in this room we have people who actually have this problem, but I'm rather sure that maybe 4 or 5 in this room that will actually have the problem that their application is requiring too much from a database that a default install can handle. Well, maybe I should count 1, 2, 3, 4, well, 5. And still then, the first reason why you have problems is because you have bad code. And then I think of 3 of my customers who actually are using GBoss and Hibernate and are running into the limits of what one single machine can do. So that's when you really need more power. How historically we do this, and yeah, I've got a problem with my screen thinks it's still in 16.9 and that one's not in 16.9, so you have to imagine that it says cluster there. And
application need to be.
Yeah, reputation. Let's see first. So, as Bernard, and I had to delete a couple of slides because he was doing part of the presentation I was funding. What you historically did was you had one database, you modified your application, you had one database where you did all the inserts and the updates, and the other ones were replications of that database, and you did only read queries from there. You put a Linux virtual server or another load balancer in front of it, and you had all the read applications on multiple machines that were read-only. Now most users don't want to modify their application because, oops, the developer left the company. So it's not like they don't want, they just can't modify, and oops, it's proprietary code, it has been compiled by, oh. So they cannot modify their application. And now we have a problem because they returned alternative flips on the screen. I might have to
Just show it in edit mode.
that was why. It's weird. I thought with this laptop I was going to have no problems with presentations anymore. Anyway, on one part you have the scaling problem, on the other side you have the high availability problem, which is actually pretty much related. Because when one server falls out, you want to have a second one that takes over. And that it actually can also handle the load of more queries, it's related. So together with the scaling problem, we started looking in a couple of years ago in how do you make a database high available, a MySQL database, because that's what most people are using. So there's this SourceForge project called MySQL.sourceforge.net, which is a bunch of scripts which don't work, which have no way to actually do a failover after you fail, so you cannot fail back. You have no guarantee that your data is actually correct. And basically it was unmaintained until 4 or 5 months ago when it came back to life. You had Pyrotest, which was a proprietary project which only worked for my ISM tables, which did not work for InnoDB, which is what most people are using. And you have a proprietary product called Emic, which is now continuing. Well, they also had problems with not all the features, and they basically, if you talk Finnish, it's fine, and if you speak English with them, it's difficult. So that was not an option. Now I have to figure out. Page now didn't work. So about 3 years ago, or 3.5 years ago, I had the same problem with one of my customers who had, on one hand, a high availability problem, and on the other hand, we saw that with the amount of data and the amount of queries we had, we were not going to scale with one machine or even 2 machines. And it was at that time that MySQL started a project called MySQL Cluster. It's code they originally bought from Ericsson, because Ericsson already did the development for them. And as MySQL has a really pluggable engine where you can put multiple engines in the same database and even use different tables with different engines, it's just another feature. Lots of clustering environments are requiring shared storage. For Oracle, for example, you need to have the data in one place, and you can then use multiple front-end machines and query the same data. MySQL has not such a thing. They have the data in multiple places. They use partitioning, so you can actually have different sets of data on different machines. But you always make sure that your data is in more than the number of replicas you have configured. So if you're only interested in scaling, and you don't care if your data disappears, you could hypothetically configure a machine or a cluster with number of replications 1. So if one machine fails, too bad, data is gone. So usually people add number of replication disks too. However, there are a couple of issues with MySQL cluster. The first thing and the biggest thing is everything they do lives in memory. Not on disk, in memory. So if you have 2 or 4 or 6 gigabytes of data, you need to have the number of replicas you want to have your data available times that amount of memory on different machines. So if you have, for example, 2 gigabytes of data, you need each machine to have 2 gigabytes. And you want to have it redundant, so you need 4 gigabytes on 2 machines spread. But you can separate that. It's a feature that got into MySQL 4.1, where 5.1, 5.2 that already. And when we started first using it, it was beta. We had a couple of hiccups. It worked, it didn't work. We started tuning queries on it, and eventually the stuff we put in production works. It's tested and works. The advantage of no shared storage is that you don't have a single point of failure, but your cost is going higher. I'm going to, since we have only 20 minutes and it's only oops, I'm going to skip through a couple of slides here. Maybe look at the architecture, which is much more interesting. Because there's an interesting thing here, and that's these are the data nodes. You can replicate data between them. And then you still have the MySQL servers, which you can actually, you might have 3 or 4 data nodes and have a whole battlefield of MySQL servers, 4, 5, 6, in front of them. And then your applications can use a load balancer to connect to any of the databases you want to. What you can do also is remove and add more machines or drop them. If you really need more performance, there's an API that directly can connect to the MySQL NDB engines, and you can query them without actually using MySQL server. But MySQL doesn't provide us how do you connect to which instance. So that's something you have to do yourself. You have to add LVS, you have to add Linux HA, or use their API, and then you can configure a list of servers which you can connect to. The components in the cluster, it's a management console that actually gives control. You have launch this node, launch that node, stop this node, create a backup of this node. You have the NDBD storage nodes. They do all the work. And you have the daemon, which is actually translating queries into get data from the data nodes. So you have an environment which you can add more and more nodes to, which you can scale, where you can put more MySQL daemons in front of it. You can add more Apaches talking to different MySQL clusters. What you still need to do is, how do I talk to which nodes? Either on how do I scale it, or which node is available. So you can either do DNS load balancing if you have a really huge farm. If you want to make sure that you always are talking to an active node, you can add RIP or VRRPD or some routing protocol that says this node is active and announce that, or you can just use Linux virtual server or a hardware load balancer. It doesn't really matter. But there's a huge but. As of MySQL 5.1, MySQL realized that there was a problem with disk limitations, that you cannot add a terabyte of memory to a machine. So they started looking into how can we put more data into the cluster. And so they added a feature which is called disk-based storage. Now even that feature name it's not exactly what they mean. They can only put a data field which has no index on top of it in disk. So even if you have a table, which I ran into, if you have 80% in a record, and if you have a record of 100% and only 80% has indexes on it, and the last 20% is the data which is not being indexed, it's only the last 20% that goes on disk. And as of today, MySQL has no roadmap into changing that for this year. They have a feature called carrier grade cluster which is a fork of 5.1.16 being paid by Alcatel. But even there, they don't need features. So this base is still, you cannot add teras and teras of data into it. But for most web applications, that's not really an issue. Apart from the fact that this base is also really, just. So when can you use MySQL cluster? If you use small data sets. Small data sets are typically user content, user preferences, everything that a 2.0 application stores, apart from log files, apart from data they are parsing, apart from geographical data. So every small kind of stuff. Typically what we've got a cluster of mine cluster nodes, mine MySQL cluster nodes in production in the Netherlands, and that's being used for session handling of one really big web application. That's typically what you can put in MySQL cluster. You can use it for HA, or you can use it to scale an application. But if you want to add geographical data, or if you want to use really large data sets, more than a couple of gigabytes, it's just not feasible yet. So we have to look at other alternatives. Typically, what you can do is, if you have a large data set, use MySQL cluster as a front end, which can handle the load concurrently and archive all the other data which you don't really need today. That's, for example, how Wikipedia works. Wikipedia has a front end, which is a cluster. And they add data, they store data, but they don't need all the same data at the same time. So they use cluster as a cache. And all the data that is being added to the cache, periodically they do select from into another table, then delete that from the cluster. It gives you the advantage of having a regular database where you can do backups, where you can have replication as it used to be working and have a read-only database. But at the same time, you can have people adding and deleting on a machine that scales much more than a regular database. Or, if you don't want to have cluster, and if you really are running into some of the bugs there, still are, and believe me, there are still bugs in cluster. I'm reporting about 2 or 3 a month. That's why MySQL asked me to go edit some books about cluster. There are still new features that are entering Falcon that are in 5.1 beta, which is partitioning in cluster. Either, as Bernard already told, you have to make sure that your application can partition itself. Yeah, on the slide that could be it, but MySQL now also supports partitioning. So rather than you creating one big table and that's my 5 minutes. Some people ask, only when it's 5 minutes, I just put it on, and then I realize it was. So MySQL has this feature called partitioning, which is something you could look into. Or, and that's another really interesting feature, is the multi-master replication, which is also pretty new. Usually in the 4.x days, when you started inserting data in slave node replication group, which meant that you couldn't use it for failover, you couldn't use it for updating data. And now we have multi-master replication, which means that you can actually add data to different nodes and still get replicated, and your replication doesn't break. So that's other research fields that I'm looking into now, how to add scaling and add more features to MySQL. I still have 4 minutes left for questions.
Just how do you, like, if you compare manual partitioning with the MySQL partitioning, because I haven't used that, how's that? Is it any good? Like?
That was not the last slide.
The previous slide,
yeah, which meant I'm still doing research on that. Or the other alternatives that I still have to explore. Partitioning in clusters certainly is a feature that is only going to be delivered to Alcatel, so nobody has even seen it.
But partitioning on the regular?
I haven't played with it. Okay. So I couldn't make any relevant comments on that. I've been too busy trying to report bugs in cluster. I couldn't look into bugs.
Is the Falcon engine good?
The problem is I'm not a DBA, and I'm only doing the work that my customers say, focus now on this, because we have to have this feature now. And that means that we try to get cluster stable, while on the other hand I said, no, we have to support the on-cluster, because these, and these features are never going to happen this year. And I should actually look into other features that my colleagues are already doing. And for example, Frederick is already doing multi-master application for a couple of customers. But I can call him if you really have questions on that, but I cannot comment on it. I could comment on Windows also, it sucks. The same kind of comment I could give on, I'm not using it, so it's not a relevant comment.
So the cluster, like, one way you could think about it is a big in-memory cache of your database that you can just...
That's one way you could use it.
Is it then very fast, or...?
It's fast. If you
Faster than a regular?
Yes. Because everything comes from memory.
Yeah, that's what
you don't need to do disk lookup. There's no
even
disk
a small
access.
database, you might say let's do it in memory because it's faster.
That's, we've been experimenting on really small databases, and rather than getting everything from disk, it's faster to do it in cluster in memory with just one node.
Yeah, that's what I was thinking. Okay.
If in case of an emergency you have to shut down all your clusters, is there a way to copy everything
They do
from...
checkpointing on disk. It's not like
Okay.
if you turn off your machines, they're gone. They do checkpointing on disks. So you can pull a node and it's being checkpointed. You can restart.
So how much do you lose? Nothing?
The last check.
It's a couple of seconds.
Okay.
It's a couple of seconds.
And it can load itself from the previous checkpoint. So
they definitely can load itself from the previous checkpoint. And syncing from one node to another. Basically, if you shut down one node, you restart it, and it starts from its last checkpoint, and then it goes verifying on the other nodes what has changed. So it's not like if you pull the cable, your power cable, everything is gone. You have checkpointing on local disks.
Is there something against this brain?
There's on heartbeats. You can get multiple amounts of nodes. You can have multiple management nodes, multiple data nodes. There are heartbeats between them all. If one management node disappears, the other one can take over. If both disappears, the data nodes start communicating between each other. They arbitrate which nodes master. It's all being taken care of. It's a product that it's being originated by Ericsson, and they needed it for their telecom equipment. So
it's a good product that's missing features.
it's a good product that missing features and that missing stability in the new features.
Yep.